Alright guys, let's talk about the average value of a function for a little bit. Okay, so let me quickly give you the definition, then I'll explain why that makes sense. If you want to know the average value of a function, what you do is you take the integral of that function over some interval, and then you divide it by the length of the interval. Okay, so in other words, if our graph looks like this, f of x on the y-axis and x on the x-axis, and let's say our function looks something like that, and here is some a value and some b value, we're going to find the area underneath the curve, and then we're going to divide it by the length of the curve. I'm sorry, the length of the interval. Okay, and kind of why this would make sense is think about average velocity. If you want to figure out the average velocity, you figure out how far you traveled and you divide it by how long it took, right? So change in displacement over change in time. And displacement, well, that's the integral of velocity, right? So if you want to find the average velocity, you take the integral of velocity and then divide by delta t. Okay, so for this drawing right here, we would just have velocity on the y-axis and then time on the x-axis. Okay, so if you want to figure out the average velocity, you take the integral of velocity and then you divide it by how long the interval is. Okay, so that's why this makes sense. B minus a is how long the interval is, so we divide by that, and then we take the integral of our function. Okay, so let me erase this, clean this up a little bit. And we can apply it to this actual situation here. Okay, so we want to take the average value of this function f of x. Okay, let's do a quick drawing of f of x equals cosine x, because I think we need to remind ourselves sometimes of what these trig graphs look like. Remember, the period for a trig function is 2 pi over b, where b is this number in between here, so obviously it's 1. So our period is 2 pi. So that means from 0 to 2 pi we can fit in exactly one wave. And remember, they are symmetrical, so that if we break them up into quarters, our life works well. So 2 pi over 4 is pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Okay, so then it's going to be broken down into these 4 parts, and it's going to wiggle in between its amplitude, right? And its amplitude is 1, so it's going to wiggle in between 1 and -1. Also remember, a cosine wave starts at its peak. So it's going to go peak, middle, bottom, middle, peak. All right, so our function is going to look like this. Okay, so let's imagine for a second they were asking us to find the average value from 0 to 2 pi. Do you think you know what the average value would be? I think it'd be 0, right? Because for every bit that we're above the x-axis, we're the same below the x-axis, right? And for every bit we're below the x-axis, we're above the x-axis. But here in this case, they're asking us to just find the average value from 0 to 3 pi over 2, right? So we're ignoring this part. So now we're going to be below the x-axis more than we are above the x-axis. So when we're all said and done, we should get a negative number, because the average value here should be negative since we're below the x-axis more than we are above. Okay, so let's go through the math and let's just make sure that that works out. Okay, so if we want to figure out the average value here, we got to divide by the length of our interval, which hopefully you can see is 3 pi over 2. And we want to take the integral from 0 to 3 pi over 2 of f of x cosine x dx. Okay, remember 1 over something is just the reciprocal, so 1 over 3 pi over 2 is 2 over 3 pi. And we got to take the antiderivative of cosine x. So let's remember, when we take the derivative of cosine x, we get negative sine x. And when we take the derivative of sine x, we get cosine x, right? Okay, so hopefully then it's easy to see. Now we're going to work backwards. Remember, integrals are working backwards. That's why we call them antiderivatives. So we want to know what has a derivative of cosine x. Sine x, right? So the antiderivative of cosine x is sine x. So we put that in, and we want to evaluate it from 0 to 3 pi over 2. All right, so we got this number out front, 2 over 3 pi, and then we're going to have sine of 3 pi over 2 minus sine of 0. And let's do some quick trig review. Remember, on the unit circle we have 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi, right? Okay, so 3 pi over 2 is down here. So we want the y-coordinate. Remember, sine is the y-coordinate. The y-coordinate here, that's going to be -1. So sine of 3 pi over 2 is -1. And then sine of 0. 0 is right here. What's the y-coordinate there? 0. Okay, so our final answer is going to be -2 over 3 pi. Sure enough, we did get a negative number. And let's try to estimate that number. Remember, pi is really close to 3. So we kind of have, I'm going to do these little squigglies for approximately equal, -2 over 9. Okay, so it's a pretty small negative number, but it's negative. Okay, so that looks good. All right, if you have any questions on this, please write them down. Bring them to class tomorrow, as always.